Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 10.2, which is going to deal with proving the slope criteria for perpendicular lines. So yesterday for 10.1, we took a look at the slope criteria for parallel lines, and that the slope of parallel lines have to be the same. Today, we're going to take a look back at perpendicular lines, and that criteria for the slope of perpendicular lines is going to help us answer our two learning goals for today. So, two learning goals for today. The first one is that you will be able to prove sides of quadrilaterals are perpendicular using the slope formula. So just like yesterday, where we went through and proved that sides were parallel using the slope formula, today we're going to prove that sides are perpendicular using the slope formula. And next, you will be able to find and prove what quadrilateral is formed by four linear equations. So I'm going to give you four linear equations. Your goal would be to go through and determine what shape they form. So with that said, let's go ahead and get into our stuff for today. And the first thing that we need to talk about is the slope criteria for perpendicular lines. So we're going to review over what that criteria was, and then use that to help us with example 1. So, two non-vertical lines are perpendicular if and only if their product of their slopes is -1. Product means multiplying, so if you were to take the two slopes, if you were to multiply them together, it would be -1. And the way that we talked about this in section 4.5, and this is exactly the same phrasing I used in 4.5, is that lines are perpendicular, have slopes that are opposite reciprocals. So that's going to be really the main thing you need to know, is that our slopes need to be opposite reciprocals. Just to refresh your memory of what an opposite reciprocal is. Opposite implies different sign, so positive to negative, negative to positive. You need to have them to be opposite. And then the reciprocal means you just flip the fraction. 4/1 or 1/4. 2/3 or 3/2. You just flip the fraction, and that's what is seen in our example right here. 3/4 and -4/3. Those two slopes result in perpendicular lines. Okay, positive 3/4 and then -4/3. So positive to negative. And then we just flipped the fraction. Now the other example I provide there is -4 and 1/4. Remember that anytime you have a whole number, it's just that over 1. So -4/1 goes to positive 1/4. Negative to positive, 4/1 to 1/4. So either positive to negative or negative to positive, and then you just flip the fraction. That is going to indicate that they are perpendicular. And the way that the homework might take you is going through and multiplying the slopes, the products. And if you were to multiply these numbers, say 3/4 and -4/3, just to show you, okay, that's going to result in -1. So if I were to do 3/4 times a -4/3, our product results in -1. So the idea is that two lines are perpendicular when their slopes, the product is -1. So just to be aware and something to look out for. So with that said, let's go ahead and take a look at our first example for today. And that's going to be to prove or show that a figure is a given type of quadrilateral. Now for example 1, part A, they want us to show that ABCD is a rectangle. So what do we know about rectangles? Well, all four angles are 90 degrees. Okay, if all four angles are 90 degrees, that means AB needs to be perpendicular to BC, BC needs to be perpendicular to CD, and CD needs to be perpendicular to AD, and AD needs to be perpendicular to AB. So we need to go through and show that all these lines are going to end up being perpendicular to each other. So our goal is to go through and identify the slope. And then we're going to use the slope to determine if they are opposite reciprocals. Now, just like in section 10.1, you can use the slope formula, the y2 minus y1 over x2 minus x1, to find the slope of all of these lines. Or you can use rise over run to determine the slope for all of these. So for the first line, I am going to go through and use the slope formula, and then I'm going to resort to rise over run for the rest of them. So the first line that we're going to focus on is AB. So slope of AB. Now to find the slope of AB using the slope formula, again, we're going to use y2 minus y1 over x2 minus x1. The point A is going to be at -3, comma -1. And then B is going to be at 1, 2, 3, up to. So it's at 3, comma 2. So to figure out the slope of AB, we're going to do y2 minus y1. So we're going to do 2 minus a -1 over x2 minus x1. So 3 minus a -3. So I now have 2 minus a -1. 2 minus a negative. Minus a negative becomes positive, so 2 plus 1 is 3. And then on the bottom we have 3 minus a -3. Again, minus a negative becomes positive, so this is 3 plus 3. So 3 plus 3 is 6. So if I have 3 over 6, okay, that would simplify down to 1/2. So the slope of AB is 1/2. All right, so that would be going through and finding the slope of a line using the slope formula. For the other three, we're just going to go through and use the counting method of rise over run to determine our slope. So we need to now find the slope of BC, CD, and AD. So let's go ahead and figure those out. Okay, so if we focus on the slope of BC, so B is right here, and we have to figure out how much we go up or down, or right or left, because again, slope is considered rise over run. So how much do we go up or down, and then how much do we go right or left? Just as a reminder from yesterday, if we're thinking about rise, if we go up, that's considered positive. If we go down, that's considered negative. If we go to the right, that's positive. If we go to the left, that's negative. So to get from B to C, if we're thinking rise over run, we go down 1, 2. So we went down 2, and then to the right 1. So rise over run, we went down 2, to the right 1. So we have -2 over 1. And -2 over 1 is just going to result in -2. So my slope for BC is -2. Now for CD, so we're going to figure out from C to D how much that is. So we go down, let's see, 1, 2, 3. So we went down 3, and then we're going to go to the left 1, 2, 3, 4, 5, and then 6. So we went down 3 to the right 6. because we're going down, that's -3. And we went to the left 6, so that's a -6. So we now have -3 over -6. 3 over 6 is going to simplify to 1/2, and negative over negative is positive. So this ends up being a positive 1/2. All right, so now we have gone through and found our slope for CD. The last one we need to find the slope for is AD. So for AD, to go from D to A, we go up 1, 2, and then we went to the left 1. So we go up 2 to the left 1. Going up is considered positive. Going left is considered negative. So it's positive 2 over 1. Positive 2 over negative 1, which is going to result in a -2. So I now have my slope for all 4 lines. We just have to go through and determine if they're opposite reciprocals. So, first ones that we need to consider. Again, we need to have a right angle in all 4 corners, so we need to look at all 4 sets of sides. So for AB and BC, are AB and BC opposite reciprocals? Is 1/2 and -2, are those opposite reciprocals? They are, because positive to negative, and then 1/2 to 2 over 1. So AB is perpendicular to BC. Next, we need to look at BC and CD. So if we look at BC and CD, so we have -2 and 1/2, and these two are also perpendicular because they're opposite reciprocals. So BC is perpendicular to CD. And then next, we need to take a look at CD and AD. So CD is 1/2 and AD is -2. 1/2 and -2 are opposite reciprocals, positive to negative, and then they are flipped. So CD is perpendicular to AD. And then the last one we need to determine is if AD is perpendicular to AB. So AD is -2. AB is 1/2, and these are also opposite reciprocals, so AD is perpendicular to AB. So I know that all 4 sets of sides are perpendicular, which results in all of the angles being 90 degrees. So I do know that this is a rectangle because the angles are all 90 degrees. And that is our answer for example 1. So we have gone through and proven that this is a rectangle. Rectangle is going to be the most time-consuming, quote-unquote, because you have to go through and find all 4 sets. There are some problems where you don't have to do all 4 sets. So that is how we do example 1, part A. Next, we're going to take a look at B, which is going to give us a trapezoid for JKLM, and we have to go through and prove that this trapezoid has 2 right angles. So that is our focus for part B. Now, if we look at our diagram for JKLM, okay, if we need 2 angles to be right angles, what 2 need to be our right angles based off the diagram? Well, based off the diagram, J and M definitely are not right angles because they're either acute or obtuse, but K and L both need to be right angles. So I need JK to be perpendicular to KL, and I need ML to be perpendicular to KL. So what we're going to do is find the slope for JK, KL, and ML, but we don't really need to worry about the slope of JM because we're not worried about these two angles. So let's go ahead and find the slope for these three lines, and then we will talk about if they are perpendicular. So let's start with JK. So the slope of JK, again, I'm going to use rise over run. Again, if you would prefer, you can use the slope formula, y2 minus y1 over x2 minus x1, if you would prefer. So to get from J to K, we go to the right 1, 2, 3, 4, 5, 6, and then we go down 1, 2. So we went to the right 6 and then down 2. We're thinking of slope as rise over run. Okay, moving up or down. In this case, -2 is on the top. And then going to the right or left is on the bottom. In this case, +6. Again, because slope is rise over run. All right, so if we have -2 over 6, can this be simplified? It can. Okay, 2/6 is going to simplify down to 1/3. And because I just have one negative, and that's on top, that means my answer is going to stay negative as well. So this is a negative 1/3. All right, next for KL, so we need to figure out the path from K to L, how much we go up or down, and then right or left. To get from K to L, we go down 1, 2, 3, and then we go to the left 1. So we go down 3 to the left 1. So that means my slope for KL, again, because we're thinking rise, how much did we go up or down? Well, we went down 3, and then run, so we went to the left 1, so -1. So I have -3 over -1. Two negatives make a positive, and then 3 over 1 is just going to turn out to be 3. So the slope for KL is just 3. All right, last one is ML. So we need to figure out the slope of ML. So to get from M to L, to go from L to M, we go up 1, and then we go to the left 1, 2, 3. So we go up 1 to the back, or to the left 3. So the rise is 1, and our run is -3. And we have 1 over -3. I cannot simplify the numbers, so that means our answer is just -1/3 for the slope of ML. So the question is, okay, we're looking at JK and KL. So are JK and KL, are these two slopes opposite reciprocals? They are, because -1/3 to +3, negative to positive, and then 1/3 to 3 over 1. And then we need to determine for ML and KL. So KL is 3, ML is -1/3. Are these two opposite reciprocals? They are, because positive to negative, 3 over 1 to 1 over 3. So that fraction is flipped. So we do have opposite reciprocals. The other way that it may ask you in the homework is they would want you to go through and figure out if the product of their slopes is -1. So if we compared JK and KL, if I did a -1/3 times 3 we get negative 1. And then if we were to do 3 times the negative 1/3, we would end up with negative 1. So what this means is that JK is perpendicular to KL, and that KL is perpendicular to ML. We know that because the slopes are opposite reciprocals. And because the product of the slopes is negative 1. So because we know the slopes are opposite reciprocals and the product, the multiplication of those slopes is negative 1, that means I know that JK is perpendicular to KL, KL is perpendicular to ML, which tells me, and what it wanted me to state at the start, that I have a trapezoid with 2 right angles. So we do have 2 angles that are 90 degrees. And that is my answer for part B, and that's how they want us to go through and do example 1. So use the diagram to go through and figure out the slope, either using the slope formula, y2 minus y1 over x2 minus x1, or rise over run. And then determine if your slopes are perpendicular because they are either opposite reciprocals or the product of their slopes is negative 1. So either they need to be opposite reciprocals or they multiply to be negative 1. So that is how you do example 1. Now on the back side, we do have another part for C where we'd go through and prove that this is a rectangle. I'm going to leave part C for you to do on your own if you would like some extra practice. C is going to be just the same format as we did with example 1A. Find the slope for all 4 lines, and then determine if they're opposite reciprocals or if their product is negative 1. And then that will tell you if you have 4 right angles, thus giving you a rectangle. So with that said, let's go ahead and move on to example 2, which is going to be our final example for today. Now, example 2 states that a city block is a quadrilateral bounded by 4 streets shown in the table. And they want us to classify what quadrilateral is formed by these 4 streets. So they give us Pine Street, Elm Road, Chestnut Street, and Cedar Road. And then they give us an equation for all 4 lines. Now, there are a couple ways that you can go through and do this. First of all, you could go through and use the Desmos graphing calculator, which I have linked on the Buzz page, which is that DESMOS graphing calculator, or you can just Google it, the Desmos graphing calculator. You can plug in all 4 of these equations and determine what shape it forms, whether it's a rectangle, a parallelogram, whatever it may be. You could look at the image it draws and determine it from there. The other way is that we can use the equations to determine what they tell us. So what we're going to do is I'm going to take all these equations and put them in y equals mx plus b form. So Pine Street being negative x plus 2y equals 4, we're going to change this to y equals mx plus b form. Okay, we're going to do that for all of them, and then we're going to look at the slopes to tell us our info. So for Pine, so we have negative x plus 2y equals 4. If I were to switch this to y equals mx plus b form, we'd have to add the x to the right and then divide by 2 to solve for y. So that's going to give us y equals 1/2 x plus 2. So from Pine Street, what is my slope? Well, slope is the number that's on x. So the number attached to x is 1/2. So that means the slope for Pine is 1/2. Next, if we look at Elm Road, so we have 2x plus y equals 7. Well, to put this in y equals mx plus b form, all I need to do is just subtract the 2x to the right. So if we do that for Elm, we're going to get y equals negative 2x plus 7. So, what is my slope for Elm Road? The number on x is negative 2. So the slope for Elm Road is negative 2. Next, for Chestnut Street, we have 2y equals x minus 6. To solve for y, I just need to get rid of this 2. So all we'd have to do is just divide 2 to this x minus 6. And when we do that, for Chestnut, we would end up with y equals 1/2 x minus 3. So the slope for Chestnut is going to be 1/2, because 1/2 is the number that's on x. And then lastly, for Cedar Road, Cedar is y plus 8 equals a negative 2x. To solve for y, all we need to do is just subtract 8 to the other side. So we end up with y equals negative 2x minus 8. So the slope for Cedar Road is going to be negative 2. So now that we have gone through, wrote the equations for all 4 of these lines, and we've gone through and identified the slope for each of these lines, we need to go through and look at 2 things. First of all, we need to determine if opposite sides are parallel. If we do, that's going to initially indicate that we have a parallelogram. Then we're going to follow up with determining if the slopes, if their product is negative 1, which means that the slopes are opposite reciprocals, which would tell us it's a rectangle. So our determination today is either it's a parallelogram or if it is also a rectangle. So first, let's go ahead and look at if it is a parallelogram. So Pine and Chestnut have the same slope of 1/2. So that means that Pine and Chestnut Street are parallel to each other. And then we also see with Elm and Cedar that they're both the same at negative 2. So that means Elm and Cedar roads are parallel to each other as well. So to kind of sum this up, we know that Pine is parallel to Chestnut. And we also know that Elm is parallel to Cedar. So, if anything at all, we know that we do have a parallelogram. The next thing to determine is if we have a rectangle. So to determine if we have a rectangle, either we can look at the slopes to see if we have opposite reciprocals, or we can multiply the slopes to see if their product is negative 1. So if I looked at Pine and Elm, because Pine is 1/2 and Elm is negative 2, if I do 1/2 times negative 2, we get negative 1. If we do elm and chestnut, so it's negative 2 times 1/2, we get negative 1. If we look at chestnut and cedar, so we have 1/2 and negative 2. If we multiply those together, we get negative 1. And then the last set would be cedar and pine. So we have negative 2 and 1/2. And if we multiply those together, we get negative 1. So the product of all the slopes is negative 1. So what does that tell us? Well, if we know that opposite sides are parallel, we know that pine is parallel to chestnut, and that elm is parallel to cedar, and if we know that the product of all the slopes is negative 1, okay, that tells us that all four corners are 90 degrees. And if we know that we have opposite sides are parallel, and we know that all four angles are 90 degrees, that tells us that we have a rectangle. So the shape, or the quadrilateral that is formed, is a rectangle. And then that's going to be our answer for part A. Now, you would run through and do the same thing for part B. Just to save time, I'm not going to run through it step by step. But again, for Clay, Fresno, Ward, and Oakland roads, you would go through and write the equations that they provide you in y equals mx plus b form. And then you're going to find the slopes, so 1/3, negative 2, 1/3, and then negative 2. Okay, first thing to consider are opposite sides, 1/3 and 1/3, parallel. And then negative 2 and negative 2 is also parallel. So I know that Clay is parallel to Ward, and Fresno is parallel to Oakland. So the question is, are there slopes, are there products, opposite reciprocals, or do the product of the slopes result in negative 1? Well, if we just look at Clay and Fresno real quick, so we have 1/3 and negative 2. We do 1/3 times negative 2. We end up with negative 0.6 repeating. So the product of my slopes in this case is not negative 1. That means that this is not going to be a rectangle. So that means it's just going to be a parallelogram. Okay, for A, yes, opposite sides were parallel because the slopes were the same for pine and chestnut, and then elm and cedar. But it was also a rectangle because the product of the slopes was negative 1. Whereas for B, okay, yes, opposite sides are parallel because they have the same slope. But when I go through and multiply the slopes, it does not result in negative 1. So A is a rectangle, B is going to be a parallelogram. If you happen to have used decimals to go through and see what the graph of them looks like, this is what the graph for part A with cedar, pine, chestnut, and elm. And then B would look like with Oakland, Fresno, Clay, and Ward. Okay, for part A, it's more precise, it's more straight, like a rectangle, whereas the parallelogram, okay, those angles are not crisp 90 degrees. Thus, it's just going to be a parallelogram. So, that is how we're going to do example 2. Go through, write the equations in y equals mx plus b form, like we did for A and then B, as I did. Look at the slope, so the number on x, and then you're going to compare the slopes. Do you have a set of opposite sides parallel, meaning are their slopes the same? Two different sets. And then if you were to multiply the slopes, would the product be negative 1? If you can answer yes to the first one, it's a parallelogram. If you can answer yes to the second one, it is a rectangle. So, with that said, that is our lesson for today on section 10.2, dealing with the slope criteria of perpendicular lines, meaning the slopes need to be opposite reciprocals, which means if I were to multiply their slopes, the product would be -1. So that is it for our lesson today on 10.2. Thank you guys for listening. As always, please do reference my completed notes as you work through the homework or check back on the video. And if you have any questions, just shoot me an email or let me know the next time you see me. So have a great day. Thank you for listening, and I will talk to you guys later. All right, bye.